So I'm Matteo Croce, and I'm in this session. I will show an overview of what we are doing with RPM copy on write. So first, what is RPM copy on write? RPM copy on write provides a better experience for RPM users by using file system reflinks. This is accomplished in different ways. First of all, it reduces the amount of I/O needed because, as the name suggests, data is not copied. Data is not copied. Then it reduces the disk space needed for package install because data is just linked, and this is very useful in those situations. For example, when you have 1 gigabyte of free disk space, and you need to do a disk upgrade, which will take like 900 megabyte of space, and you need twice the space, first for the download, for the package download, and then for the actual extraction. And also it optimizes the CPU usage because what happens with the current package install is that during the download step, the CPU is almost idle, and this RPM cow moves the decompression from the installation step to the download step to optimize the resources. The performance depends on the content of the package. It can vary. We observe that the gain is bigger when a package contains a few big files, and the gain is less when a package contains a lot of small files. But anyway, the gain can never be negative, so it's a win situation. A bit overview of what the reflink is for people who doesn't know reflinks. Well, reflinks are similar to hard links, but they have some differences. First, only the file content is shared and not the inode. So what happens with the hard link is that when you change the metadata of a file, of a copy, if you change the owner, the permission, the selling attributes, or whatever, you change the metadata for every copy of the file. This doesn't happen with the reflinks because the inode are different, and only the content is shared. It works on block level. Again, while hard link can only link the whole file, with reflink you can clone a portion of the file, like the first, the end, or something in the middle. The only requirement is that the start and the end of the data you want to reflink must be a multiple of the block, the file system block size, which usually is 4K. And then another key difference is that when you have hard links, if you change the content of a copy, all the other copies gets the same modification. And this doesn't happen with the reflinks because when you try to write on your own copy, this is immediately unshared, and you don't alter the other copies of the same file. The software support of reflink is good because it is present in the kernel for something like 9 years. It's supported by Btrfs and XFS, which are our file system for Fedora and CentOS, and partially by ZFS, but not very well tested yet. And it's provided by a simple IOCTL file clone reg, so it's even simpler to use. So the key component of the RPM cow implementation is the extent file. What is the extent file? The extent file is an RPM file, but with some difference, a different magic. The file content is decompressed, So it's not deflate, zip, XZ or whatever, it's just plain data. And the file, inside the archive, every file, the content of every file starts at the boundary of a block. So the start of every file inside the archive is a multiple of the sector block size, which is 4K usually. The extent file is generated with a tool called RPM2 extent. In the classic Unix way, like it's a streaming operation, so it can reach the input package from the standard input and print the extent file on the standard output. And this is another key component because since it can work in streaming mode, it can work on the fly. For example, if you get a package from some repo, and then you pipe to RPM2 extent and you save to the extent file on disk. So what happens in practice when you install packages with RPM cow? The difference with the stock RPM, I mean. So with stock RPM, the installation of a package is basically done in 3 steps. You have the package download, and then you have the installation, which is done, which means the data is decompressed and written to the file to the destination path. And then we have the script execution as usual. With RPM cow, things are a bit different because we have the download, which is made a bit different. The package is downloaded, but in parallel, RPM extent is transcoding the package file to the extent format I showed just a few minutes ago. Then there is the installation, which yet is different because since the extent file is uncompressed and the data is aligned on the file system boundary, the file is just reflinked to the final destination. So which means for every file in the archive, RPM creates an empty file and reflink the content from the origin, from the archive to the destination. Script as usual. So with this technology, let's say we can skip the IO copy of the data because we just reflink the component from the directory, which is the usual archive file in var, dnf, something. So some practical example. If we try to run some, let's say, synthetic performance test on like install two the same package with without cow to see the difference. For example, I tried to install LibreOffice Core with the stock RPM, and on my desktop computer, it needed 4 seconds and something to install the package. While with RPM cow, it needed 700 milliseconds to install the same package from the extent file. This is just a time comparison. If I try to do some more detailed statistic, for example, I try to install another big package. I chose this package because it was big and contained a lot of files. It was a file containing fonts basically, and with perf stat we can see that both the task clock, every metric is better with RPM cow, like the time, the switches, the page fault, everything. Anyway, this is not a real life test because when we install package, we don't use RPM directly. We use DNF, and most of the time we also download the package from the network. And also because in this case I was assuming that the package was already transcoded. So we also have some real world performance tests. For example, I did this test with 3 different packages, which are more or less the worst, average, and best cases for RPM cow. The first one, which is the worst case because contains a lot of smallish files. It's a DNF install of Firefox, which on my computer took 30 seconds. And with RPM Cow, it took 29 seconds, more or less. So in the worst case, it's just a bit better. But what the important thing is that it's never slower than stock RPM. Another test with medium-sized with a package containing medium-sized files. So the selection of the CLang compiler, the time dropped from 11 seconds to 9 seconds, which is roughly 10-13% improvement, more or less. So it's decent, I'd say. And keep in mind that this is the time of the whole operation, like done with DNF, like download, install, and scriptlet. So everything. And the best case operation is there is this package, Linux firmware, which contains a few big files. When I say big file, I mean more than half megabyte, more or less, which is enough to show a huge improvement. So the package installation dropped from 9 seconds to 5 seconds and something with this package. So this is I can say that RPM Cow is not like a silver bullet, because there are some situations where it can't work. For example, there is still an ongoing discussion with the community, because to transcode the file, at the moment the signature validation is done after the decompression, because the moment that the compression is made in a pipe when downloading is done by RPM2 extent in the download step. We want to fix this. We are investigating. We are trying different solutions. Like we proposed a Merkle tree, or even better, a hashed, segmented hashed, like interleaving a file, the package file with some hashes in the middle, so we can download the chunk, validate, and pass it to the decompression. This is still an ongoing project. It doesn't work on system with separate partition, because since DNF stores the package files in var cache DNF something, when you try to reflink the file data, the reflink can't pass the mount point boundary. So you need to use a single file system for rootfs and var. Otherwise, nothing bad happen. Just when there is a problem with a cow, for example, the file system doesn't support, or there is the cache is on a separate partition. The data is just copied as usual, so nothing bad happens, but it works without cow. And yes, it doesn't work with the file system. Well, it works only with file system with reflink support, and sadly, X4 doesn't support reflinks at the moment. So the authors of the RPM Cow, the original authors were Matteo Almond, David Cavalca, Manu Bretel, and Richard Fibel. I just helping with porting with CentOS 10 and adding some features and everything. And if you want to know more, we have some resources. We have a wiki page on Fedora with the more detailed the description of how cow is and how it works. There are the repositories. There are 3 repositories. We have the first one is RPM itself with the RPM code. Yes, and I want to note that most of the code in RPM is in a separate plugin called the RPM plugin reflink, just to keep the code simpler. And the other repos are librepo, which is the library to handle the DNF repository. and the DNF plugin cow, because the DNF plugin, which basically is the DNF plugin, which during the download step, instead of storing the packages as they are, it runs RPM2 extend to transcode the file to the reflink format. And I also have the number I shown in the previous slide, like was Firefox, Silang, whatever. I took them from simple install test which I recorded on Askinema, and which is I published on the internet if you want to have a look on how it worked and how I enabled it and the timing, everything. I put it online just. And that's it. If someone has some question.
I want it now. Give it. Give me.
Matteo, if you are using the work Chrome setup, you might not be able to read the questions. Luna's asking if you plan to support this in DNF5 and make the packages available in distributions.
Okay. Sorry. Okay. Well, support in DNF5. RPM cow support is basically in RPM. The only thing in DNF is the DNF plugin, which basically runs RPM2 extent during the download step. So the only thing we need is to convert the DNF plugin from 4 to 5. I have this on my to-do list, and yes, I'm planning to put in DNF5. While the work for librepo is already done, and the work for RPM is already done. And for Fedora, I know that in Fedora uses a new version of RPM, which basically the RPM team migrated from C to C++, but I already ported the RPM code base to C++. So yes. Other question or?
Hi, this is Robbie. I have one question. I'm sorry. So you're saying that the larger the files contained within the RPM, the better the performance you get with the copy and write?
Yes, because what happens when you install files with RPM cow? You create an empty file just to get the path, and then there is you call the syscall to link the data from the archive to the destination, and magically the destination file is filled with all the data. So you skip the regular copy, because what is the usual approach is to open the input file, open the destination file, read, write. So basically RPM cow, it's avoiding you to do a lot of read and write, but you still have to create the destination files, set permission and close and whatever. So obviously if this is skipping the file, the content copy, the more data you need to copy, the bigger is the gain you are getting.
Awesome. Cool. Thank you.
You're welcome.